Welcome back. In this video, I'll be walking you through differential calculus. Our outline for this video is, the first one is definition, first principle, general formula method, which is also known as general techniques, second derivative, differentiation rules, which is function of function, can also be called chain rule, product rule, quotient rule, and implicit function. At the end of this video, you should be able to work on all this. Now, this is Further Solution Academy, Further Solutions Academy. Please subscribe and share our video. Further Solutions Academy. Further Solutions Academy. Now, the first one is definition. Definition. Now, if I'm talking about definition of definition. Now, in calculus, this is differential calculus, but in this calculus, we have two branches, which is called integration and differentiation. Integration and differentiation. Now, but here is the origin of it. I have y equals to x. This is my y and x. They are both variable. They are both variable, which is what? This one is known as independent and dependent. Independent and what? Independent. It means this can change on its own, but change on this will affect this. Change on this will affect this. Okay, change on that will affect the other one. Now, this is how it always be. I have of my y, I have of my x. Now, this is x axis, this is y axis. Now, this is known as real axis. X is always real. That is why in mathematics we always find x. Find x. Why this is what? Imaginary axis. Now, imaginary axis. Now, the change on x will affect the change on what? On y. The change on x will affect the change on y. Now, if I have x and y, this is known as coordinates. They are known as what? Coordinates. It's known as coordinates. Coordinates. Now, this is known as coordinates. Now, it's known as coordinates. X is considered first before y. X is considered first before what? Y. If I have a particular point like this, I have another point like this. Now, my x1, my y1, both of them interact together to form it. It means this point is coordinate x1, coordinate y1. That is this point. Okay. I have another point here, which is coordinate s2 and y2. S2 and what? Y2. Now, I have a curve. This is my curve. Now, if I want to find the gradient of this curve now, this is my gradient of this point, of this curve. Now, it means what is happening here, this is changing what? Y. This is changing in what? X. And how do I do the change in x? Y2 minus y1. I mean S2 minus S1, Y2 minus Y1. It means final minus what? Initial. My final, this is my final point, this is my initial. Now, by so doing that, now I can now call this change in Y all over change in X, which is also can be called what? Slope. Which is also can be called what? Gradient. which can be also called what? Some my textbook will put m. I can also call it y prime. I can also call it f of s prime. All this refer to what? What is happening here. All this refer to what is happening here. Now, okay, that is all about definition. Now, this will now lead me, take us to what? To first principle. First principle. My first principle, okay. Now, if I have something like that, that is known as what? Differential calculus. Now, this will now take me to what? First principle. First principle. Now, this one will take me to first principle. Now, in first principle, just know that my dy, the x, is not the same thing as what? Delta y all over delta x. Note that. This is known as total derivative. Why this is called partial derivative? Total derivative and partial derivative. Now, okay, I think next video I'll work more on limit of a function. When limit is said to be differentiable, is differentiable at the point wherever. Now, okay, if I have something like this, my total derivative is always equals to delta y all over delta x. Sorry, there will be a limit of delta x tends to 0, which is delta y all over delta x, can be equals to limit of delta x tends to 0, which is open a bracket of f of x plus delta x minus f of x divided by delta x. Now, this can be used for first principle. Now, we can test for this when it's differentiable and not differentiable. We can now work on it, maybe our next class. Now, this is our limit. When limit comes, when you limit your delta x, it becomes a what? Total derivative. The differential total derivative. For instance, example, if I have something like this, y equals to x squared, using first principle. Now, I can use this approach, or I use general approach, which is, I can see that y plus delta y equals to x plus delta x all square. It means if there is change in x, also there will be a change in y. Now, I will have delta y equals to x plus delta x squared. My delta x squared will surely be what? 2s, okay, x squared plus 2x delta x plus delta x all squared minus my y. What is my y? My y is what? X squared, which is x squared plus 2x delta x plus delta all squared minus what? X squared. This will cancel this. Now, once I have that, my delta y equals to what? 2x. I can factor out delta x, bracket of 2x plus what? Delta x. Divide both sides by delta x. This will cancel this. Now, it means my delta x, y all over delta x equals to what? 2x plus what? Delta x. Limit delta x to 0. It means when I limit, at the point of limit, the y, the x will be equals to what? Limit of delta x to 0, which is what? Delta y all over delta x. It will be equals to 2x plus what is 0. Now, at this point, my dy, dx, it will be equals to 2x. That is my final answer. That is my final answer. That is called total derivative. Okay. That is called total derivative. Now, I can use this to get the same thing. My function, it will be what? What is my x? I have my x, function of x. Okay, I have and so on. You do the same, and function of x is what? Is this? It means that my f of x is what? Is x squared, and what? Function of x is what? Is x. And by so doing that, I will have my what? My final answer. Okay. I don't need much time on that. I don't want to waste much time on first principle. Now, okay. This will now take us to general techniques, which is general formula. General formula. Method. General formula method. Now, if I'm talking about general formula, my dy, if I have y equals to what? Ax raised to power n. Ax raised to power n. It means my dy, find dy dx. It means dy dx of this function is n will come down, a s n minus 1. That is my final answer for that. Now, I can use these particular techniques to solve any problem. For instance, I have a particular question. Let me play around with these questions. I have some question here. Okay, if I have y, find dy dx of the following. Okay, the first one is I have y equals to minus 12x squared. I have y, another one is y equals to 4x cubed. Another one is y equals to root of x. Another one is y equals to 1 over x root of x. And the last one is, this is 4. And the last one is y 5. Y equals to, y can be equals to, let me use 1. Okay, y equals to, let me use something like this. Okay, let me use x squared, x cubed minus 1 over root of x. That's going to be a bit normal. Okay. Now, let's try to solve this question. This one, solution. Now, this one, the y dx of this one is y equals to minus 12x squared. It means y equals to dy. The x can also call y prime, which is also called slope, also called gradient, also called f of s prime, is what? Minus 12 bracket of 2 x raised to power 2 minus 1, which is equals to my dy dx. It will be equals to what? Minus 24s. That is my final answer. Minus 24s. That's my final answer. Now, the next one, I have x raised to power. It means y equals to 4x cubed. Dy dx is 12, which is what? 4 bracket of 3 x 3 minus 1, which is what? 12. I have 12, which is 12 x squared. 12x squared. That is for that one. The second one, the third one, if I have something like this, y equals to root of x, I can write it as well as x raised to the power 1 all over 2. It means the y, the x, it will be equals to what? X 1 all over 2, 1 all over 2 minus 1, which I will have 3, the y, the x, it will be equals to 1 all over 2, 1 all over 2, x raised to the power minus 1 all over 2. Now, I can write this back to your indices. X raised to the power minus is written as 1 all over x squared. Therefore, if that is the case, I can write my answer as what? Which also implies 1 divided by 2s 1 all over 2. I can, as far as this, I can also write it as 1 all over 2 root of what? X. That is my final answer for that one. I can write this, I can write this, I can write this. Any of them is what is answer. Okay, the next one is y equals to 1 divide x root of what? X. Now, note, just note this case. Note, x root of x is not the same thing as x and what? This one is telling us x multiplied by what? X raised to the power 1 over 2, which is also, this one is telling us x raised to the power 1 all over x. They are different things. This one is called root form, surd form, while this one is called root form. That is called root form. The first one is surd form, while the second one is what? Root form. Take note of that very well. Take note of it very well. Now, if I have this with the help of my indices, I can write it as well as 1 all over what? X multiplied by x raised to the power 1 over 2. They are of the same base. Therefore, I can say that my y is equals to what? 1 all over what? S1 plus 1 all over 2, which also implies 1 all over x, which is 2, 3. I have 3 all over 2. 3 all over 2. Now, my y is equals to 1 all over 1, which also I can write it as well as what? X raised to power minus 3 all over 2. Minus 3 all over 2. Now, my dy, dx, it will be equals to minus 3 all over 2. I have x raised to power minus 3 all over 2 minus what? 1. Which is, I have minus 5. Now, it will be what? My dy. The x, it will be what? My dy, the x, to be equals to minus 3 all over 2, which is also s minus 5 all over 2. Now, my final answer can be presented as what? As well as minus 3 all over 2, 2x raised to power 5 all over 2, which also can be like this, minus 3 all over 2, 2 root of what? S powering what? 5. Anyway, anyhow, they are the same thing. Anyway, anyhow, they are the same thing. Okay. That is my final answer for that. The last one, which is number 5. I have y equals to s cubed minus 1 all over root of x. Now, with the help of my indices, I can write this as s cubed minus x raised to power minus 1 all over 2. I can write that is possible. I can say that what? I cannot do that. My y, the dx is equals to 3x squared minus 1 all over 2 minus brackets, and my x will be what? Minus 1 over 2 minus 1. Okay, which I will have my dy, dx, it will be equals to 3x squared plus, minus times plus, minus and minus is what? Is plus. 1 all over 2, x raised to power minus 3 all over 2. Which also the same thing as 3x squared plus, I have 1 all over 2 x raised to power 3 all over 2, which also the same thing as x squared plus 1 divide 2 root of what? S bracket of what? Of 3. I can write it like this. I can also write it like this. I can write it like this. They are the same thing, depending on what you are working towards. That is all about general techniques. That's all about general techniques. Now, this now will take us to special derivative. Special derivative. Now, my special derivative. Now, there are some things that you need to, there are special cases. Special derivative. Now, my special derivative. Okay, let me have some function here that are special in deriving them, and let me have derivative here. Result. Okay. Now, let me start with lim and exponential. If I have lim x, this also implies lim log base both base exponential and x. Now, this and this, they are the same thing. They are the same thing. Now, if I want to differentiate this, it means my dx is what? 1 all over x. There is proof on it. We can use our first principle to generate that, but just know this is their result. Now, this is equals to this. The next one is exponential. If I have my exponential x, if I differentiate my exponential x, then as what? E exponential. It won't be any different. Now, if I have sine x, if I differentiate, these are trigonometry ratio. Trigonometry ratio, we have sine, we have cos, we have tan. They are trigonometry ratio. If I differentiate this, I will have cos x. Now, if I now differentiate cos x, I will have minus sine x. If I differentiate tan x, I will have sec square x. If I now, these three, they are known as what? Trigonometry ratio. Each of them has reciprocal. Each of them has reciprocal. The one of tan, we have cot x. If I differentiate cot x to be what? Cosec square x. And also, if I differentiate, I have the one of tan. Okay, the one of cos, it should be, my derivative of course is secant x. If I differentiate my secant x, it will be what? Secant x, and what? And tan x. Secant x tan x. If I'm also, the last one is cosec x. Cosec x. This one will be what? Cosec x and cot x. Cosec x and cot x. Okay, these are all special derivative. These are all special derivative. The first one is lim, which is also called log exponential ex. Number x. Okay, e, which is an exponential, and also sine. Now, the one that have c, look at c here, c here, c here. They are all having minus. Minus will be here. And also, the one of that, my cot will also have minus. It means my c, the c here, the one that starts with c, it will be, well, their derivative will end with what? Minus. That's how to know that. This is all about what? Derivative function, special derivative. Now, let me move move on to second derivative. Second derivative. Now, my second derivative. If you are talking about second derivative, for instance, if I have, we have talked about dy dx. Now, if I differentiate 2 times, for instance, I have a function of anx, okay, xn. Find d square. I can call it y prime prime. I can call it f of x prime. I can call it. Now, and in the application sense of it, this can be my what? This can be my displacement. Now, I can ask you to find the what? Find the acceleration. Find the acceleration. When I mention acceleration, it means I'm to move on from what? Displacement. From displacement to what? To velocity. Velocity to what? Acceleration. It means I'm to differentiate it 2 times. Now, if somebody asks me to find what? This in that case. Okay, it means dy dx it will be equals to what? A x n raised to the power n minus 1. That is my final derivative. This is first. Now, my second one to be d square y all over what? S square y. I mean x equals to what? N bracket of n minus 1. A. It will be what? X raised to the power n minus 1 bracket of minus 1. Which also can be what? Can also implies what? A bracket of n minus 1 n raised to the power what? N minus 2. That is my final answer. I can undo it and so on and so forth. There is one of higher one. I can do it to what? To any level, to even to last time. If it is my last time, it means what? My d of what? And I will talk about that next video. Okay. For instance, we are asked to find these problems. Find d square y all over x square y of if y equals to 4x squared minus 7 all over x. Now, I have this type of problem to solve. Okay, how do I find this type of question? Now, it means solution. Now, y equals to what? 4x squared minus 7 all over x. I can also write this as 4x squared minus 7x minus 1. I can write this way like this. Okay. I can answer that what? Dy dx. It will be what? 8x minus bracket of 1 7x. It will be what? Minus 2. Now, which also can implies what? 8x plus 7x. Now, if I am looking for what I'm asked to find, squared, it means I will have 8 plus bracket of 2. I have what? 7. I have what? S2, which is 3. I will minus 1 from this. I have 3. That is my final answer. Which I can also write it as what? 8 minus 14 x raised to the power 3. Which also the same thing as what? My dy dx can be equals to what? My dy dx can be equals my d square y all over ds square to be what? 8 minus 14 all over x cubed. I can write this. I can write it like this. I can write it like this. Also, I can write it like that. That is my final answer. Okay. That is my final answer. Hope there's any problem. No. Okay. Okay. Okay, another question is, if I have another problem, I have cos x, I have cos x, I have, okay, let me not use cos now, let me not use any of the trigonometry now. I have e raised to power x. Now, e raised to power x. If I'm to find the square of this, it means I will just have what? My dy, y equals to e raised to power x, d square y, all over what? D all over, d dy dx, it to be what? Ex. D square y, all over what? There won't be any change of x, it will be what? Ex. That is my final answer. That is my final. So like that, that's how going to be repeating himself. Okay. Let's move on to differentiation rules. Differentiation what? Rules. Differentiation rules. These differentiation rules will be working on function of function differentiation rules. Differentiation rules. Okay. Differentiation. I'm not trying to differentiation rules. Differentiation rules. Now, which are what? Function of function, chain rule, also called chain rule, product rule, and quotient rule. Let me start with function of function. Function of function. Function of function can also be called chain rule. Can also be called chain rule. Rule or function of function of a function. Now, if I have y equals to a plus b, all divided by what? All into what? X raised to power. Okay. Let me have x raised to power. Okay, if I have ax plus b powering what? Powering a number. Find dy, the x of this function. Now, if I should have this particular problem and I'm asked to find dy dx of this question. Now, the first thing I will do is that let y equals to what? Un. And my u is equals to what? An plus b. The u, the x, the y du. The y du is equals to what? N minus 1. Y du, the x, it will be what? A. Now, my dy, the x, it will be what? Dy du multiplied by du dx, which is also what? N minus 1 multiplied by also a. My final answer will now be dy, the x. It will be, what is my n? What is my a? I have a, which is, my u is what? U is bracket of ax plus b or bracket of n minus 1. That is my final answer. That is my final answer. Now, this particular point, this is the what? The chain rule. This is the rule that You need to what? Note it out. Note it out. Just note it. Okay. Okay. If I have, let me write out some problem that very nice to play around with. Okay, for instance, I have a question like this. Okay, I have y equals to 4 all over s squared plus 1 squared. That is number one. Number two, I have another one of this case. If I have cos x, okay, cos y equals to cos 3x plus, okay, 3x, let me put to be nice like this. And the last one is, which is number 3. Let me have another one of, okay, sine cube y equals to sine cube bracket of 3x plus 10. Now, okay, they are good. Okay, this is 10. If I want to solve this question, I'm to find dy ds of 10. I want to find the y ds of 10. Now, the first one, solution. The first one, I will have y4 divided by x squared plus 1 squared. This can be written as what? 4 bracket of s squared plus 1 minus 2. Now, my dy, the x of this is, how do I do? I can say that what? Let y equals to 4u raised to power, let me not use u raised to power minus 2. Now, and my u is equals to s squared plus 1. The y, the u, it will be equals to 4, which is 8 minus u minus 3. And also, which is what? The u, the x, it will be equals to 2x. Okay. Okay. Now, my dy, the x, it will be du, dy all over du, multiplied by du all over the x. Now, which also implies minus 8u, multiplied by 2x. It means my dy, the x, it will be equals to, I have 2 times, I have 16 minus x, and my u, what is my u? My u is what? Is this. I have s squared plus 1 or minus what? 3. My final answer can now be presented as what? 16x all divided by x squared plus 1 bracket of what? 3. That is my final answer. That is my final answer. Now, let's move on to number 2. Move on to number 2. I have y equals to cos 3x plus. I will just say let y equals to cos u. Dy, dy, du, it will be equals to minus sine u. And my u is equals to 3x squared plus 2x. Du, the x to be 6x plus 2. Therefore, dy, the x, it will be what? Dy, the x multiply by du dx, which is also implies minus sine u multiply by what? 6x plus 2. Now, I will now present my answer this way. Dy dx, it will be equals to, what is my, I have minus, okay, bracket of 6x plus 2 sine, what is my u? 3x squared plus what? 2x. That is my final answer. That is my final answer. Okay, the third one, which is the last one. The third one, which is the last one. I have y equals to sine cube 3x plus 10. Now, note, if I have y equals to sine square x, I can also write it as what? Y equals to, is also implied as what? Sine s or bracket of square. I can write this like this. Now, since they are equal, I can use the approach to solve this problem here. Now, trigonometry, we have to work on it. It's a very nice, it's a nice concept in calculus. Now, y it will be equals to what? I have sine what? 3x plus 10 or bracket of what? Q. I can also let y equals to what? U raised to power 3. Now, my u is equals to sine 3x plus 10. Therefore, dy du, it will be equals to 3u squared. Du dx, it will be equals to, I will differentiate inside, I will have 3. The easiest way of differentiating something like this, differentiate core, which is inside, I have 3. Differentiate outside, I will have cos, and repeat what is here, 3s plus 10. 3s plus, okay, 3s plus 10. Now, I can now write my answer, my dy dx, it will be equals to du all over dx multiplied by what? Du all over dx, which is also implies we have 3u squared multiplied by 3 cos 3x plus 10. Now, my final answer can now be what? Dy dx. It will be equals to, what is my, this times this, I have 9. I have cos 3x plus 10, close your bracket, and multiply by, what is my u? My u is everything there, which is sine 3x plus 10. That is my final answer. That is my final answer. Okay, that is my final answer of that. Okay, the shortest way of doing it, if you are writing it in objective, like your JAM or one or this objective question, and you have question to differentiate, I have to do that very fast. I have to do that very fast. For instance, let me write out some questions. Okay, I have one question here. Y equals to 2s cubed plus 2s squared plus 1 in raised to power 4. Now, you want to do this very fine. I'm finding dy dx. Now, what I will just do is that bring down this. I will have 4. Dy dx. I will write 4. Differentiate inside. If I differentiate inside, it will give me 6x squared plus 4x. Write what is here again, which is what? I have 2s3 plus 2s cubed plus 1 minus 1 from the hop, which is what? 3. That is my final answer. The first thing is bring down the power, differentiate inside, write it out, and write what is here and minus 1 from the power. That is my final answer. Those are the short way of differentiating. Okay, let's move on to product rule. My product rule. Now, my product rule is always like this: y equals to uv, where my u and v are functions of x. They are function of what? Of x. They are function of x. Okay. It means my dy, the x, it is equals to u dv all over what? Dx plus v du all over dx. I can also write this as uv prime plus vu prime. They are all the same. They are all the same. Now, that is all about that. Okay, let me have some problem to play around this with. Okay, if I have some problem like this, I have okay, number one, y equals to x sine 2x 2. I have 3x squared plus 1 s3 minus 10. Okay, another one is if I have s squared sine bracket of s sine bracket of s raised to power, let me use 2 plus 10. Now I want to differentiate these problems. Now this is number 3, y equals to. Okay, I want to, they are all y equals to. There must be a y equals to. I want to differentiate them with respect of what? X. Find the y dx of them. Find the y dx of them. Now, we are finding the y dx of them. Solution. Now, y equals to x sine x. Let u equals to x and v equals to sine x. Du dx is equals to 1. dv dx is equals to cos x. Cos x. Now, I will now present my answer this way. Note the y, the x, it will be equals to u dv dx plus v du dx. Now, which implies, what is my u? My u is s, dv dx. dv dx is what? Is cos x plus, what is my v? My v is sine x. What is my du dx? Is 1. Now, my final answer is what? dy dx to be equals to s cos s plus sine x. That is my final answer. That is my final answer. Now, if I have something like this, number 2, I have y equals to 3s squared plus 1 and s cubed. Now, I will just say let u equals to 3s squared plus 1 and v equals to s cubed minus 10. Du dx, it will be what? 6x. dv dx, it will be what? 3s squared. Now, the next thing is what? Dy dx to be u dv dx plus what? v du dx, which implies what is my du dx? What is my u? I have 3s squared plus 1. dv dx is what? 3x squared plus, what is my u? My u is 3x, x squared minus 10. The v, the u, the x is 6x. I can now present my answer dy, dx, it will be equals to, if I like, I can factor out. There won't be any cracks. I can open brackets if I want to do it. I can turn it to what? 9x raised to power 4 plus 3x squared plus what? Plus 6x4 minus what? 60x, which I can now do this one being what? 15, which also the same thing as dy dx is equals to 15x raised to power 4 plus what? Plus 3x squared minus 6x, 60x, which also implies I can factor out x the same way, which I have 15x raised to power 3 plus 3x plus minus 60. Now, any of them, I can write it as my answer. That is my final answer for that. Now, the last question on this part, I have y equals to sine. I have y equals to, okay, I have x squared sine x squared plus 10, or bracket of. Okay, I'm asked to differentiate this. Okay, my u, let u equals to x squared. V equals to sine x squared plus 10. Now, my du, the x is equals to 2x. The v, the x is equals to, differentiate inside. I will have 2x. I want to use fast method now. 2x. Differentiate outside. I will have what? Cos x. Repeat what is there, which is what? X squared plus 10. That's all. That's all. Now, I will now move on by having dy, the x, which is equals to u dv all over dx plus v du all over dx. What is my u? My u is equals to x squared. Dv dx is 2x multiplied by 2x bracket of, 2x cos x squared plus 10 plus, what is my v? I have sine x squared plus 10. What is my, the u dx is what? 2x. Now, which I can now present my answer this way. The u, the y dx is equals to, I can put it 2s3 and cos x squared plus 10 plus 2x sine x plus 10, which I can factor out something which is 2x if I want to do, but it's not. You can also write it this way: 2x into big bracket of x squared cos s plus 10 plus sine x squared plus 1. That's my final answer. That's my final answer. I can write this, I can write this way, any of them. Now, that's my final answer. Okay, let's move on to the third rule, which is called quotient rule. Quotient rule. Now, quotient rule. My quotient rule. My quotient rule is always like y equals to what? U all over v, where v and u are function of x. It means my dy dx to be equals to v du all over the x minus minus u dv dx divided by v square. Now, example of this. Let's work on these two problems. Okay. Example of it is, the first one is, if I have y equals to 4x squared plus 8 divided by 2x squared plus 8. That is fine. Okay, let me see. Plus 3. Plus 3. Okay. And number 2. If I have y equals to root of 1 minus x all over 1 plus x. 1 minus x all over 1 plus x. Okay, let's do the upper bit plus, why this one be minus. Okay. Now, simple to go. Let's start from number 1. Number one. Solution. Y is equals to 4x squared plus 8 all over 2x squared plus 3. Let u equals to what? 4x squared plus 8, and my v equals to what? 2x squared plus 3. du dx is equals to what? 8x. dv dx is equals to 4x. Now I will now move on by having what? dy dx. It will be equals to v du dx minus what? u dv dx all over v square. Now, which implies, what is my u? My v is 2s squared plus 3. My du dx is 8 minus, what is my u? My u is 4s squared plus 8. My dv is 4x divided by, what is my v? My v is 2s plus 3 all squared, which I can now present, I can answer what? dy dx can be equals to, 8 is common, I can bring out 4, I can open bracket as well. I can say that 16s cubed plus 24x minus 16s cubed plus what? 32x divided by 2x squared plus 3 all squared, which also the same thing as what? I think cube, they can cancel themselves and run out of this and this, 24 and 32 and 24, which is what? 6, which is 5, 56. I can say that what? 50, they are both of x. 56x divided by 2x squared plus 3 all bracket of square. That is my final answer. Can I write it that way? Okay. 16, 24, 20, 32. Okay. The second one is, I have this particular question. I have y equals to root of 1 plus x all over 1 minus x. I can write this as x 1 plus x all over 1 minus x all root. I can also write this as 1 plus x all bracket of 1 over 2 divided by 1 minus x all bracket of 1 over 2. Anyway, anyhow. Dy, the x to be equals to, okay, before we do that, let u equals to 1 plus x and v equals to 1 minus x. The u, the x, it will be equals to, differentiate inside, I will have 1. Bring down the power, 1 all over 2. 1 times 1 all over 2. Repeat what is here, 1 plus x, bracket of minus 1 from up, which is minus 1 all over 2. Minus 1 all over 2. Now that is the first, this is function of function. It means I differentiate inside, I have 1. Bring down the power, and I differentiate, I repeat what is here, and minus 1 from the up. Which is, I can do the same thing also, the v, the x. Differentiate inside, I will have minus 1. Bring down the power 1 all over 2, and also repeat what is a and what minus 1 over 2. That is my final answer, which I can now write it with the help of indices. I can answer what? Now, okay, I can now use application of indices here and go. Okay, dy, the x, it will be equals to v du all over dx plus minus u dv all over dx all over v square. Now, which implies, what is my u? What is my v? My v is 1x bracket of, what is my du? My du is 1 all over 2, and if I like, there won't be any crisis if I have 1 divided by 2 bracket of what? 1 plus x all bracket 1 all over 2. Okay. Minus, what is my v? My u. My u is 1 plus x bracket of 1 all over 2. My dv, I have bracket 1 all over 2, which is what? Bracket of what? 1 minus x 1 over 2. Now, divided by my v square. What is my v square? I can now, my v square is 1 minus x all bracket of 1 over 2 times 2, which is going to be what? 2. Which is, this will cancel this. Now, I cannot present this. What can I do here? What can I do here? I know this one will become plus. That is plus. To become plus. Okay. Okay. Is there anything I can do? I can say that what? My dy, the x, can be equals to 1 minus x, 1 minus s, bracket of 1 all over 2, divided by 2 bracket of what? 1 plus x plus I have 1 plus x root of 1 over 2 divided by 2 bracket of 1 minus x all divided by 1 minus x. Now we can now simplify further. Is there any how you can simplify further? Okay. Their LCM, find the LCM of the upper part and also start and move on. Now, that's our final answer for that's not the final, but you can simplify further. by finding this, the LCM of these two. By finding the LCM of this. Now, let's move on to another one, which is called implicit. Implicit function. Now, that's my implicit function. You can have xy equals to s squared y. Now, they are products of each other. Now, it means I have to apply my product rule. I will differentiate one and attach it to another one, which is u, which is v. U and v. Now, if I differentiate u, I will have 1 and what? Which is 1y. Plus, if I differentiate y, I will have x dy dx. When I'm differentiating my y, it will be attached with what? The y dx, which is equals to, I differentiate u also, I have 2xy plus s squared dy dx. Now, this is the what? Product rule of them. I'm using product rule because I'm now focusing on that my y is known as independent. I can now collect like times by having s dy dx minus s squared dy dx, which is equals to 2xy minus y. I can also have dy dx to be s minus s squared equals to 2xy. Now, dy dx to be equals to what? 2y minus y, which I can write it as, okay, which I have this, dy dx, it will be equals to, I can write this as y, bracket of x minus 1, divided by, this also s is common, I have x, bracket of what? 1 minus x, which is my final answer. Now, that is called implicit function. Implicit function. Implicit function. Okay. Implicit function. Let me give more example. If I have y squared s plus 3x squared y equals to 1. Find the y dx. If I'm to find the y dx of this particular function, now the first one is u and also y, v. U and v is very important. Differentiate u first. I will have 2y dy dx. 2yx dy dx plus, if I differentiate this, I will have y squared. Now, this one is standing for this, is standing for this. This is standing for this. Now, plus, I can bring out my 3. Differentiate mine. You can differentiate mine. This u, I have 2xy, which is normal, bracket of, differentiate also, I will have plus x squared dy dx. If I differentiate the constant, becoming what is 0, equals to 0. Now I can now move on by having 2yx dy dx plus y squared plus what? 6xy plus 3x squared dy dx equals to 0. This and this, they are the same. I can also have 2yx dy dx plus 3xy dy dx equals to, I have minus bracket of y squared plus 6xy, because these two cross to the other side of it. I multiply and subtract this from both sides. Now, okay, I can answer what the y, the x can be equals to what? 2yx plus 3x squared, which is the same thing as what? Minus y squared minus 6xy, which I can also write this as minus y bracket of y plus 6x. Can I divide both sides by, which is divide both sides by what? 2y. I can bring out x also, bracket of what? I can bring out y, x, bracket of 2y plus 3x, close your bracket. Now, which is 2yx plus 3x. This cancel this, and this also. Now, it means my dy, the x is equals to what? Y bracket of y plus 6x divided by x bracket of 2y plus 3x. That is my final answer. That is all about implicit function. Now, try this and get back to us. Drop your comment after. If there is any need for help, surely be. Now, the first one is if I have a function of this case, okay, if I have a function of y equals to 3x squared plus 7 bracket of 1 over 2. Find the y, the x. The second one is if I have a question of this, y equals to sine 3x all over e raised to power minus 2x. Okay, and the last one is if I have find the y, the x. And the last one is if I have 50x cubed plus 36xy plus 5y squared equals to minus 2. Try this, drop your comment. This is Further Solution Academy. Thanks for watching.